Okay, so what's a hyperbola? So the best way to find out is to fill in this table of values. You may use your calculator to assist you. So you do 1 over negative 5. What's 1 over negative 5? It's, so you just type this, 1 over negative 5, you get negative 0.2. Yes, that's right, negative 0.2. So write in decimal, negative 0.2. And do the next one, you get negative 0.5, negative 1, and then keep it going. If you need a calculator, come to the front. Continue, keep going. So it's up to negative 0.5, you get negative 2. What's the next one? If you use your calculator, you get negative 5. And then if you sub to 0, you get error. So there's nothing at 0. And then keep going, 5, 2, 1, 0.5, 0.2. Right. Make sense? Yeah, hi. Yeah. So basically, you're going to draw this graph on the right-hand side. So put in the x-axis, thank you, x, put in the y, and the numbers are, there's going to be a lot of numbers. So 2, 4, 6, 8, and then do the other one, negative 2, negative 4, negative 6, negative 8, and try to plot the points. So we'll just label the axis first, negative 2, negative 4, negative 6, negative 8. Okay, something like this. Let's plot some points. So I've got the graphy. Okay, let's see. The first one is, some points are a bit hard to plot. Point 2 is 5. Let me use a different color pen. Let's use green. So the first one, green. So 0.5, 0.2 is 5, which is here. And what's the next one? 0.5 is 2. Yeah. Reverse way. Oh yeah, I'm going to do negative. Yeah, I'll do the positive first. Yeah. So 1, 1 is this point. And then 0.2 is 0.2. No, 2 is 0.5. And then what's the next one? 5 is 0.2. So it gets very small quickly. Yeah, so plot these points, and same for the other one, negative 5, which is over here, very close to the x-axis. And then negative 2 is 0.5. And then negative 1. And then here. Hopefully you can see. Alright, so if you join the dots, let me try to join the dots. So you get this graph that looks like this. Right. Okay. So you get this graph. That's a curve, but getting closer to the x-axis and the y-axis. And then there's another one here. Right, so that's what it will look like. That's called a hyperbola. Okay, so two graphs. It's almost like two separate graphs. There's one here and one there. So we'll call them branches. There are two branches. One branch, the second branch. They're disconnected. And you'll notice that this graph has two asymptotes. So the exponential has got one. A hyperbola got two asymptotes. There's one here, which you put a dotted line in red. There's a horizontal asymptote. There's a vertical asymptote. So both of these, they just get closer and closer, but never reaches. Okay? So that's your hyperbola. Y equal to 1 over x. Okay, let me write down the equation. Y equal to 1 over x. Okay? Alright, and then try to do another one and see what the effect is when there's a 2 in front. Okay? And fill in this table of values and then draw it. Okay, have a try. Okay, so you will see that the 2 on the top just doubles. So just double what the previous value is, double this, doubles. Nothing here. 10, 4, 2, 1.4. Okay, so it just doubles. So if you double, let's see what effect it has on the graph. So let's start with 0.2 is 10. And then 0.5 is 0.5 is 4. And then 1 is 2. And then 2 is 1. And 5 is 0.4. Something like this. So if I were to draw it, it looks like this. So it's just stretch out a little bit. Something like this. And then you have something like that. Just stretch out a bit. Okay, I should put the points first. -2, -1, 1, -2, 0.5 is 4. Something like that. Alright, so if you join the dots, it looks something like this. Okay, good. So they have the same asymptote, except that the 2 on the top just stretches out the graph. So you just stretch this out, a bit stretch out. But they still have the same asymptote. You'll still approach the x and y axis. So we're going to write down in summary. So basically the graph of this has got one vertical asymptote. There's a vertical line here that gets closer and closer, and there's a one horizontal asymptote. So there's 2 asymptotes. So the effect of A in A over X, the A on the top is the bigger value of A, the more the graph stretches out. As we can see in this example, having a 2 there makes the graph more stretched out. So the purple one compared to the green one. Okay. What else are there? Now, if you have a negative in front, let's say I have a different pen. Let's use a black one. Okay. So the graph of this is a reflection of 1 over x about the x-axis. Okay. Now, how do we know? So if I draw it, it will look like this. So if I try to draw -1 of x on this graph, it will look like this. It will be, actually, I won't draw it there because it will be confusing. Okay, so if I draw it here, if you have a negative, the graph will look like this. You can verify that using table of values. Okay, so negative x and then y. Okay. Alright, good. Right, continue. Okay, now we also have to answer a question about the domain and range. What's the domain of this graph? What do you think the domain is? Well, it's everything, isn't it? Except what number? Except 0. So it's all real x except x equal to 0. Okay. How about the range? All real y except y equal to 0. That's cool. Okay, that's not all. We have to do more practice. So there's some more practice question on the next page. So as you can see, we're not going to do a table of values each time. We just have to memorize the shape of the graph and just draw it accordingly. Okay, so I'm going to do some practice examples on the next page where you get to sketch these graphs without doing table of values. So have a look at this one. So you got the graph y equal to 2 over x. You know what the graph look like. What does it look like? It looks like this. So you just draw 2 branches. One branch here. Oops. Let's try again. Draw a branch. Something like this. Draw another branch. Make sure you approach the x and y axis. And then you have to show the points where x equal to 1 and -1. So what that means is you substitute x equal to 1 y equal to 2 over 1, which is 2. So 1, 2. So 1, 2. So passes through this point. And also passes through when x is negative 1, y is 2 over negative 1, which is negative 2. So it goes 1, negative 1, negative 2. Does that make sense? So make sure you show these points, the questions say. And then asymptote. So make sure you label the asymptote. So just make sure you put a dotted line on the x-axis, dotted line on the y-axis. So you need to show the asymptote as well as the curve. And of course label xc, that's your x-axis, that's your y-axis. Okay? I'll try the next one. Continue on, next one. So next one is the same thing, except when there's a negative, just remember it goes on the different branches. You will go on the second quadrant as well as the fourth quadrant. Okay, just memorize that as a fact. Arrows on both ends and put x and y. They all look the same except that you will pass through different points. So therefore, you have to substitute x equal to 1. Find out what the y value is. Y is negative 3. So 1, negative 3 will be here. 1, negative 3. Alright, pass through to this point. 1, negative 3. And then the other one, negative 1, 3 as well. So if I put x is negative 1, y is positive 3. Negative 1, positive 3. Alright, does that make sense? How we sketch these hyperbolas. Hyperbola. I think that's all. And then we're going to do some questions that involve point intersections. See where the graph crosses this graph. Find the coordinates of the points where 1 over x intersect these lines. So if I draw it, so let's draw y equal to 1 over x, which is over here. Okay, y equal to 1 over x is drawn. And then what you need to do, you can see that if I draw the line y equal to 3, it's a horizontal line that crosses at one point here. Okay, that's y equal to 3. So you have to find what that point is, point of intersection. Okay, so how do I find that? We solve them simultaneously. So to solve simultaneously, you just have to make them equal, right? So that means 1 over x equal to 3, and 1 equal to 3x, x is 1/3. Okay, so you just use algebra. So how do I use algebra? Multiply both sides by x, right? And then divide both sides by 3. So once you get the x value, the y value is known already. So the point intersection is, POI, is x is 1/3, y is 3. Okay, so that point intersection is 1/3, 3. Does that make sense? Alright, try the next one, see where they cross. Okay, so let's draw the hyperbola again. Okay, that's drawn. And then you draw the line y equal to 4x. So you draw here. Let's try again, sorry. Just the arrows too big. Okay, so we'll draw y equal to 4x. Yep. You need to do the working. Yeah. Yeah, let me draw the line first. So y equal to 4x. So it's a very steep line. This is y equal to 4x. So clearly it crosses at 2 points, right? So what do you do, Damien? How do you solve simultaneously? Yep. So you write 4x equal to 1 over x. Yep. Unfortunately, well, firstly, 5x equal to 1 gives you 1 point. Clearly, there's 2 points. Now, you won't get plus or minus if you just get 5x equal to 1. I think the next step is to multiply both sides by x. And what do you get? 4x squared, not 5x. Not adding, you're timesing. Right? And that's where you get the 2 solution because there's a square. So x squared is a quarter. What's x equal to? Plus or minus square root of a quarter, which is a half, right? Plus or minus a half. So we found the x value. How to find the y value? Just substitute into the first one. So when x is half, y equal to 4 times half, which is 2. Or x equal to negative half, y equal to 4 times negative half, which is negative 2. Okay, so we get the 2 points. Let's label these 2 points on there. So the first point is x equal to half, comma 2. The other one is negative half, comma negative 2. Right, so these are the algebraic skills that involve to find the point intersection of lines and the hyperbola. And also, there's some curve sketching you have to do. Make sure you show the asymptotes. The graph always look the same. They always have 2 asymptotes. Okay, so you do exercise 9K today. All right, off you start. Thank you. 9K. Yeah.